calculating the electrical service for a commercial laundromat, it's essential to apply appropriate demand factors to account for the fact that not all equipment will operate at its maximum rated load simultaneously. This helps prevent oversizing the electrical service and reduces costs. Let's examine the demand factors that can be applied to various types of equipment commonly found in a commercial laundromat, including washers, dryers, lighting, small appliances, and heating, ventilation, and air conditioning, or HVAC systems. For washers, assuming all washers are operating simultaneously, a peak demand factor of 100% is generally used. This means that the full rated load of all the washers must be considered in the calculation. However, a diversity factor can be applied to adjust for the probability that not all washers will be operating at the same time. A typical diversity factor for washers is 0.90. For dryers, to account for potential surges in demand during peak usage periods, a peak demand factor of 125% is often used. Similar to washers, a diversity factor can also be applied to dryers to adjust for the probability that not all dryers will be operating simultaneously. A typical diversity factor for dryers is 0.85. Other demand factors can also be applied to other loads in the laundromat. Firstly, for lighting, a demand factor of 0.10 is often used, assuming a typical lighting load. Secondly, for small appliances, to account for appliances such as irons and vending machines, a demand factor of 0.5 is applied. Thirdly, for heating, ventilation, and air conditioning, assuming a typical heating, ventilation, and air conditioning load, a demand factor of 0.20 can be used. To calculate the total electrical demand, multiply the total installed load by the demand factor for each type of equipment. The formula for this calculation is total electrical demand equals the washer load multiplied by the washer demand factor, plus the dryer load multiplied by the dryer demand factor, plus the lighting load multiplied by the lighting demand factor, plus the small appliance load multiplied by the small appliance demand factor, plus the heating, ventilation, and air conditioning load multiplied by the heating, ventilation, and air conditioning demand factor. Let's consider an example with the following assumptions. Firstly, 51 washers with a capacity of 20 to 80 pounds each. Secondly, 30 dryers. Thirdly, a 10 kilowatt lighting load. Fourthly, a 5 kilowatt small appliance load. And fifthly, a 20 kilowatt heating, ventilation, and air conditioning load. To estimate the load of the washers, let's assume that each washer draws 20 amps at 208 volts, which equates to approximately 3.464 kilowatts per washer on a three-phase system. However, for simplicity in this example, we'll use 20 kilowatts per washer for the calculation. For the dryers, we will assume that each dryer has a rating of 15 kilowatts. Note that it is important to verify the actual ratings of the appliances being used, as it can significantly change the calculations. Using these assumptions, the total electrical demand can be calculated as follows. The washer load is 51 washers multiplied by 20 kilowatts multiplied by a 100% demand factor multiplied by a 0.90 diversity factor, which equals 91.8 kilowatts. The dryer load is 30 dryers multiplied by 15 kilowatts multiplied by a 125% demand factor multiplied by a 0.85 diversity factor, which equals 478.125 kilowatts. The lighting load is 10 kilowatts multiplied by a 0.10 demand factor, which equals 1 kilowatt. The small appliance load is 5 kilowatts multiplied by a 0.5 demand factor, which equals 0.25 kilowatts. The heating, ventilation, and air conditioning load is 20 kilowatts multiplied by a 0.20 demand factor, which equals 4 kilowatts. Adding these values together, the total electrical demand is 91.8 kilowatts plus 478.125 kilowatts plus 1 kilowatt plus 0.25 kilowatts plus 4 kilowatts, which equals 575.175 kilowatts. To determine the total three-phase demand, divide the total three-phase load, which is the washer load of 91.8 kilowatts, by 1.732, which results in 53 kilowatts. To determine the total one-phase demand, divide the total one-phase load, which is the dryer load of 478.125 kilowatts, by 1, resulting in 478.125 kilowatts. It's important to consult the local electrical codes and regulations to ensure that the demand factors used are compliant. The National Electrical Code, also known as NEC, provides guidance on demand factors for various types of loads. It is important to note that the example and assumptions here are for illustrative purposes only. Always use the actual ratings of the equipment and consult with a qualified electrician or engineer to determine the appropriate demand factors for your specific installation. The demand factors and calculations provided here are intended to be a general guide and may not be applicable to all situations. Other factors, such as the specific type of equipment used, the operating hours of the laundromat, and the local climate, may also need to be considered. In addition to the demand factors for specific equipment, it's also important to consider the overall diversity factor for the entire laundromat. The diversity factor is the ratio of the maximum demand of the entire facility to the sum of the individual maximum demands of all the equipment. A diversity factor of less than 1 indicates that the maximum demand of the entire facility will be less than the sum of the individual maximum demands of all the equipment. This is because not all equipment will be operating at its maximum demand simultaneously. For example, if the sum of the individual maximum demands of all the equipment in a laundromat is 200 kilowatts, but the maximum demand of the entire facility is only 150 kilowatts, then the diversity factor is 150 kilowatts divided by 200 kilowatts, which equals 0.75. The diversity factor can be used to further reduce the size of the electrical service required for the laundromat. However, it's important to use a diversity factor that is appropriate for the specific installation and to consult with a qualified electrician or engineer to determine the appropriate value. In addition to the demand factors and diversity factors, it's also important to consider the voltage drop in the electrical system. Voltage drop is the reduction in voltage that occurs as electricity flows through the conductors from the source to the load. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. To minimize voltage drop, it's important to use conductors that are large enough to carry the required current and to keep the length of the conductors as short as possible. The NEC provides guidance on the minimum conductor size required for various types of loads and the maximum allowable voltage drop in the electrical system. Proper grounding is also critical for electrical safety in a commercial laundromat. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock and to prevent damage to equipment. The NEC requires that all electrical equipment in a commercial laundromat be properly grounded. This includes the metal enclosures of the equipment, as well as the grounding conductors that run with the circuit conductors. Ground fault circuit interrupters, also known as GFCIs, are also required in certain areas of a commercial laundromat, such as near sinks and other wet locations. GFCIs are designed to detect small amounts of current leakage to ground and to quickly interrupt the circuit, which helps to prevent electric shock. Regular maintenance of the electrical system is essential to ensure its safe and reliable operation. This includes inspecting the equipment for signs of wear and tear, tightening connections, and testing the GFCIs. It's also important to keep the electrical panel clean and free of obstructions. A qualified electrician should be hired to perform regular maintenance on the electrical system. In summary, calculating the electrical service for a commercial laundromat requires careful consideration of the demand factors for various types of equipment, the overall diversity factor for the facility, the voltage drop in the electrical system, and proper grounding. Consulting with a qualified electrician or engineer is essential to ensure that the electrical system is properly designed and installed. By following these guidelines, you can ensure that the electrical system for your commercial laundromat is safe, reliable, and efficient. This helps to minimize energy costs and to provide a comfortable and safe environment for your customers. Remember to always consult the latest edition of the National Electrical Code and any local electrical codes or regulations that may apply. These codes and regulations provide specific requirements for electrical installations in commercial buildings, including laundromats. In addition to the technical aspects of electrical service calculations, it's also important to consider the economic aspects. Oversizing the electrical service can result in higher installation costs and higher energy bills. However, undersizing the electrical service can result in equipment malfunction and downtime. Therefore, it's important to carefully consider all of the factors involved and to make informed decisions about the size of the electrical service. Obtaining multiple bids from qualified electrical contractors is also a good way to ensure that you are getting the best value for your money. Be sure to compare the bids carefully and to ask questions about any discrepancies. Finally, it's important to remember that electrical work can be dangerous. Only qualified electricians should perform electrical work. Never attempt to perform electrical work yourself unless you are properly trained and licensed. By following these safety precautions, you can help to prevent electric shock and other electrical hazards. To reiterate, firstly, determine the total connected load for each type of equipment, including washers, dryers, lighting, heating, ventilation, and air conditioning and small appliances. Secondly, apply the appropriate demand factors to each type of equipment. These factors account for the fact that not all equipment will be operating at its maximum load simultaneously. Typical demand factors are 100% for washers, 125% for dryers, 10% for lighting, 5% for small appliances, and 20% for heating, ventilation, and air conditioning. Thirdly, calculate the total electrical demand by multiplying the total connected load by the demand factor for each type of equipment and then summing the results. The formula is total electrical demand equals the sum of the product of the connected load and the demand factor for each type of equipment. Fourthly, consider the overall diversity factor for the entire laundromat. The diversity factor is the ratio of the maximum demand of the entire facility to the sum of the individual maximum demands of all the equipment. Fifthly, calculate the size of the electrical service required based on the total electrical demand and the diversity factor. The electrical service must be large enough to handle the maximum demand of the laundromat. Sixthly, consider the voltage drop in the electrical system. Voltage drop is the reduction in voltage that occurs as electricity flows through the conductors from the source to the load. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Seventhly, ensure proper grounding of all electrical equipment. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock and to prevent damage to equipment. Eighthly, install ground fault circuit interrupters in wet locations. Ground fault circuit interrupters are designed to detect small amounts of current leakage to ground and to quickly interrupt the circuit, which helps to prevent electric shock. Ninthly, perform regular maintenance of the electrical system. This includes inspecting the equipment for signs of wear and tear, tightening connections, and testing the ground fault circuit interrupters. And tenthly, consult with a qualified electrician or engineer. A qualified electrician or engineer can help you to properly design and install the electrical system for your commercial laundromat.